beam slab building. That's the case what we did in our example. Okay, beam slab building. How many stories do we have? We have 4 stories. We have 4 stories. Number of bays 2, in X direction 2, in Y direction. In X direction we have, what was 5 meters I think. In Y direction we had 3.5. Story height is 4. Okay. Now that's three difference, beam slab, number of stories 4. In X direction we have 2 bays, in Y 2 bays. Story height 3, bay width is 5 meters, 3.5 meters. Instead of this using comma, okay, comma, this is using comma, 3.5 meters. Okay. We have slabs also, you see, slabs, A-sec1. For example, define frame sections. What are frames? Let's see them. Frame sections, modify. They are steel. Okay, this is a steel frame. Or we can create another concrete. Let's make them concrete. This is a similar structure, okay? Not exactly the same structure. Assign frame sections. This is a similar structure. What about our area? Area sections. Modify. Okay, this is 25 meter. Let's 0.12. 0.12. Let's change them also. Okay. This is a similar structure to our building. Extrude view. Okay. Now we need to define mass source. Mass source will be defined here. Define mass source. Okay. Now here we have some options. You can take mass source from element and additional masses or from loads. We will choose this one, from loads. Okay. Let's define our loads. Okay, my computer is now open. There are loads. Okay, let me explain this mass source. From element and additional masses or from loads. And from element and additional masses and loads. Now our element weights are included in G, okay? In G load case. Therefore, I don't need element from element, okay? I don't need this one, from element loads, element weights. I will select only from loads. And for example, if we have G here, we don't have G now. For G, we will select 1. For Q, we will select 0.3 because the codes require that. Okay. Let's switch to my computer. Define mass source from loads. Which loads? I will include G, multiplier will be 1. and I'm going to include Q, and multiply will be 0.3, okay? 30% of Q will be included in the mass. Niye kimse beni dinlemiyor? Herkes önünde telefon. Beni niye dinlemiyorsunuz? Ha? Anlamıyor musunuz? Yok siz dinliyorsunuz da çoğu kişi dinlemiyor. Anlamıyor musunuz? Ne zor geliyor? Yani merak ettiğim için söylüyorum. Çok mu konu ağır geliyor? Veya ne bileyim, yorgun musunuz? Nedir? Okay. This is our mass source. 100% of G and 30% of Q. Okay. We defined as mass source. File, same model. Let's say the model. Now let's make the model analysis. Okay. Let's run only model analysis. Okay, this is model analysis. What is model analysis? In model analysis, we determine the dynamic properties of the structure. For example, this structure in x direction is moving with a period 0.48 seconds. 0.48 seconds means one cycle of its movement will be completed in 0.48 seconds. This is period. One cycle will be in 0.48 seconds. Okay? This is typical for a 4-story structure. If you have, for example, 10-story, then your period will be about 1 second. This is 4-story building. It is about 0.4 seconds. And what about, this is first mode. What about second mode? This is the torsion mode. Okay. In Turkey, burulma mode. Burulma. This is mode because in torsion. And the third mode will be in Y direction. This is second mode in Y direction. This is second mode in Y. Okay. This is second mode in Y direction. We have some also torsion because the stiffnesses of these columns are larger than the other one, than the other columns over the other part. Okay, this is second mode, and it's 0.45, very similar to X. Okay, these are periods, and using these periods, you can calculate equivalent earthquake loads over the structure. Equivalent earthquake loads, and these loads are these equivalent loads. Fx, Fy. In X direction this, in Y direction this one. Now let's assign them. Stop animation. In order to assign loads, we need to define first rigid body constraints. Rigid body. Now, select all, first of all, rigid diaphragm. Assign frame. Assign joint constraints from here. Assign joint constraints. We are going to need to define diaphragm. Rigid diaphragm enables all stories to behave as a rigid slab, okay? As a rigid. There will not be any movement inside the diaphragm. Is this understood? Rigid diaphragm. For example, if this is our story, our slab, okay? If you define rigid diaphragm, your slab will move like this one. Okay? Like this. There will not be any different displacements among any other points. All points will move like this one. It cannot bend like this one or like this one, or it cannot get shortened. This is rigid diaphragm. Anlaşıldı mı? Türkçe'de anlatayım. Rigid diyafram olduğunda bu bütün olarak yani bu kendi içerisinde hiç hareket etmiyor. Rigid. Kendi içinde hareket ediyor. Bütün olarak. Zaten beam slab buildinglerde genelde bu kabulü yapıyoruz. Yapmasanız da olur ama yapsanız da olur. Yapalım şimdi burada. Nasıl yapıyoruz? Now we are define this constraint. We first select everything, all nodes. Select all nodes. And then select diaphragm here. Add new constraint. Okay, diaphragm 1. Constraint axis in z-axis and assign a different diaphragm constraint at each different selected z level. Click on this one. At each level, we are going to have another diaphragm. Okay? For example, let's click on this point. You see, this is diaphragm 112. We have a diaphragm. All these points at the top is included in diaphragm 112. Okay. Click on this one, diaphragm 112. But this point will be included in diaphragm 19 at z equals 9 level. This is at z equals 6 level. Okay. Now we are going to assign these horizontal loads. These are horizontal loads. We are going to assign them here, but first we need to define horizontal loads. We defined, not here, define load patterns. Now we need to define A, X, positive. This E means, E stands for earthquake, X in X direction, P is positive eccentricity. What is eccentricity? In eccentricity, we assume that the earthquake load will be applied not in the center of mass, a little bit eccentric load. A little bit we have eccentricity. This is center of mass, this point, but the load will be applied a little bit farther from the center. This is called eccentricity. If the eccentricity may be on both sides, okay? I'm going to select one and it will be positive, the other one will be negative. Okay? Eccentricity. Now, EXP, I will define EXP 0 and select wave. And I will define EXN, for example. Then EYP, EYN for negative eccentricity. Okay. EXP, EYX, and EYP, EYN. Okay. Now, how am I going to assign these loads? Now, we come here again, define load patterns. This is quake load, right? EXP. Modify load pattern. Okay, here. For EXP, select user loads. For EXP, select user loads. Okay. And click on modify lateral load pattern. Similarly, for EXN, select user loads. Okay, modify and modify load pattern. And we are going to write loads here. And EYP, user loads, modify, you see. We are going to define our lateral loads here. User loads, modify. Now in next direction, EXP, these will be the loads. FX 40, 46, 47, 54, that's right, 47, 54, what else? 47, 54, 38, 22, 38, 38, 22. These are the loads in next direction for EXP. And apply center of mass. This is the eccentricity. 0.0.5. Okay, this is EXP. Now for EXN, same loads, 54, 38, 38. What was that? Sorry, 46, 47, 50, 47, 50. 36, 46, and 22. And eccentricity is negative. Negative. Okay. And for Y direction, we will choose this one. 40, again, same. 48, 48, 55. 48, 55, 55. 39, 22. 39, 39, 22. Eccentricity will be 0.05, and for this case, this will be Fy. What is that? 48, 55, 39. 48, 55, 39, 22. And negative eccentricity. This is for EX and EYN. What about EYP? I did in wrong place. Not FX should be 0, this should be FY. 39, 22. And these all will be 0. Okay. Now after defining all these loads, we need to define these load combinations. We have 1.4G, 1.6G. G plus Q plus EXP, 0.3 EY. These EY are without eccentricity. For example, we can do combinations like this. Define load combinations, add new combo. Combination 1. Let's say this is Duchenne combination. we have 1.4G, 1.4G, 1.4. What about Q? 1.6Q. Q, select Q, and scale factor will be 1.6. Okay, this is called Duché combination. Okay, what else? For example, this one, dx1, dx2, dx3, these will be the names. dx1 will be dx1 will be 1g plus 1q plus dxn 0.3, 0.02, 0.3 dxn. This is another combination. Add another combo where, or let's copy of combo and change this one dxn. This is dx2. Okay. Now this is another combo. We are going to define all combinations here. And how many combinations here we have? I think 8, 16, 17 combinations. Okay. After defining all 17 combinations, we will have another combination, envelope combination. Envelope combination will give you the maximum of all these combinations. Add new combo, envelope, or in Turkish zarf, let's write zarf. And envelope, you see envelope. Select here envelope and select dx1 and select dx2 and select Duché. Okay. Now this combination, this zarf combination, will give me maximum of all these other combinations. This is called envelope combination. Otherwise, we cannot find which one gives high values. Click on OK, and that's it. Now we can run the structure, run the analysis, run all cases. Run. Now this is model. Now I don't want model. Let's say under G loading, you see under G loading, this will be the deflection. And under EX loading, EXP loading, for example, this will be displacement due to horizontal forces. This is EXN, negative eccentricity. This is EYP, and this is EYN. These are the displacements. What about moment lag or reactions? Let's see reactions. Okay, this is reactions due to, or let's see moment diagrams. Moment diagrams due to Duché loading. This is moment diagram due to Duché loading. Moment diagram due to Duché loading. And what about moment diagram due to dx1? Moment diagram due to dx2, dx3. This is zarf. Zarf, you see in zarf, this blue one and red one are positive minimum and maximum values. Blue and, for example, we have maximum, we have two maximum values. Shear V2, for example. In one combination we have negative 10, this is minus minimum, and in another combination we have negative 50. This is the maximum. Okay, this zarf gives us maximum and minimum envelope. It is given. For example, for maximum, this is. For minimum, this is the case. And both of them are shown here. These are very important. But I don't know why you couldn't listen to this. Is this too hard for you to understand? Okay. Okay then. We forgot something.